Been a bit bummed out, Andrew, lately. Maybe you can cheer me up, my man. Hopefully these are really good conversational models, not just physics and physicists and things like that.
Smart people. Today I am joined with a number of participants in the HUGS Summer School program for nuclear physics grad students. Now, I've made a number of videos sort of detailing what my research is and what I'm doing in grad school, but I mentioned in one of my most recent vlogs that up until I started this school, I really didn't know what else was out there in the world of nuclear physics. So I thought it would be a good idea for a video to get together with a lot of the participants in HUGS and learn about what they do, and also answer some of the questions you all left in my community.
First nuclear reactor
so
failed
I figured
because of a lover's
we'd have a bit of a discussion about each other's research interests and kind of just let the conversation steer towards, whatever questions and comments we have about each other's research and overall experiences in nuclear physics. Okay, cool. So let's go ahead and start off with like a show of hands. I want to get a feel for who here is more of a theorist. 1, 2, 3. Arun, you're not a theorist this whole time?
I took both pills.
Okay, that makes sense.
Some things are nuclear, and the theoretic value.
It made no sense to me when you introduced your PhD advisor and he was an experimentalist. I was like, that's so interesting how you're a theorist.
Experiment of a very different
okay, so we got 3 theorists. So then,
clearly not at the nuclear level of elements with radioactive decay states,
so it seems like we're actually
isotopes that are not
pretty diverse in that respect. So
in the form,
I guess we can just start off with everyone kind of introducing themselves and give me an elevator pitch of what your research interests are. And, throughout this, we'll just ask questions and make comments throughout this video.
The stock market?
Okay. So, actually, the first person on my screen is Jingyi.
What makes those
you
numbers?
Tell us a little bit about yourself, your research,
with the gaggle count,
those kinds of interests.
Okay. Yeah, so my name is Jingyi Zhou. I'm the Vice and Fourth Year grad student.
Like I said, it's been a rough one today, Andrew.
So, my physics experiment is the elastic compton scattering of helium-3
Compton scattering.
Facility
I love the
located
feedback
at
scatter
the
pattern on
University
whatever it is you're doing. I mean,
if you can give me, if
you can give me a machine terminal, that is where I use Compton scattering. I have to have a vector integral from these things come down into a scatter pattern of its spectrum on a Hubble 45. I mean, how is it any different? Not theoretically, mathematically. It would be theoretical math. It would be derivative lambda on derivative time, right? And whatever you got if you want A level physics, it's going to be AX equals not X, not L, not anything else. You got to go element, and it's actually a little faster to do it this way because the conventional training method on it just goes. And I don't need to so much worry about elements. Obviously, it has a capstone at the nuclear level. It's because it's physical, it becomes real, so you base all the math off of it, right? And that's the Compton scattering of the function. Mathematically, as we talk about the snowflakes here and cyclical transitory, the transit of the cyclical function that is psi. It is this wave function by vector positions in these systems. And remember, it doesn't matter what you apply to. Don't be afraid to be a psychologist, an engineer. Compton scattering is the same way you learn nuclear fission. Literally the same process. You guys all have capital advantages. Firstly, you're posted in a tag or a flag for the market. I have to. It's in the nuclear, enriching the photon of the lattice structure of foam theory and the internal lattice structure confinement with one-dimensional magnetic gas that keep that nuclear fusion 5 megatons to 15 megatons in the enriched state where it actually allows the total release of because about the decay, the goo at the end of it, where it's great in the form, but we don't have the lattice structure. The lattice structure makes the refinement of that system where the decay is a neutron or durium or tritium. One of them goes over to CERN as the byproduct to actually help CERN make 115 or 114, 115. by
Because for proton, we
no,
can
no,
use
no,
the
that's calcium and
hydrogen
plutonium.
obviously.
They're trying
But for
for
neutron,
16,
as what
17,
I
and
said, we
18
have
with
to
the
use something
neutrino
that can,
as a, I would imagine at that top end is going to be a
so
trifecta of a
that
collision,
is one of the
or a ramp and a
And that's
slow
because you can't
with
just have
a collision or
collection of
something like,
neutrons, right? They'll
it's
decay.
in chemistry they do the definition by like, so the most easiest one is certain things are soluble in water,
Gotcha.
but at a certain temperature. If
I've never
not, they're
heard
not.
of the proton charge radius puzzle. Could you give me one sentence summary of that?
Oh, sure. Maybe I can. So, actually,
Well, some of the problem with it is the theoretical value goes way out front.
So, in general, there are two
Click a
different
Cthulhu
types of
over here
experiments
back before
to
everything
measure
and
the
way the hell
proton
out
charge
front.
radius.
Mathematically,
One is using the spectroscopy
we
technique,
are fixed
and
to
the
the
other is,
technology.
EP
That
elastic
would be
scattering.
about where this
So
is.
around,
Maybe what can kind of come up happening that looks clear in the mix.
2010, so you can see
Our
that actually,
gaps
there
are
two different
still applied
kinds
into
of,
that overall terminal. There's always gaps in the stone mill, and that's why you go to the energy efficiency. You know, the same Jaguar saw program is the same technical information that goes into the nuclear reactor. It has to be. It can't not be. Obviously, they are two different things, but they work in identical ways to this function. And well, it kills you is why it's not business management an ideal study of nuclear fission. It doesn't need to be as comprehensive as these nuclear physicists are, but, nuclear physicists have managers. What job is it that they do? Obviously, elements, cost, timelines, crew, systems. Sounds like EM, electricity, magnetisms, when there's actually a magnet in there, or how the wires all go into it.
Okay. So I guess next we can go to.
It's like I never get the
Philip.
question. It's like I don't have
Tell us a little bit about
any
your
of
research.
this to even compare. So I wouldn't even know.
I'm a
And
grad student at
I
CUNY
couldn't have one of these conversations. There's no reason. Because, like I said, what am I supposed to do? Walk downtown with it after studying nuclear fission and just apply it in the grocery store? I want you to think about the moral applications, Oppenheimer. What happens next?
So a lot of us learn in like high school or early college that what you have